We are honored to have Paul Hidalgo, Cloud Business Development Manager, Asia Pacific, Middle East, and Africa, Trend Micro, to share with us how to continuously adapt to threats.
Good afternoon. It's strange to have Alexa introduce me. I have an Alexa at home, and I didn't know that you can do it for this thing. All right. So, all right. So I'm Paul. I'm a solution architect for Trend Micro. I'm here to talk about DevSecOps. So, DevSecOps is basically how you can automatically secure your environments in AWS. Just to give you a background, before I was a solution architect for Trend Micro, I used to work as a cloud architect and a security architect. In fact, trivia, my manager in my old job is here. He's sitting amongst you guys here. So it's pretty cool, all right? So let's talk about, before we talk about security, DevSecOps, I'm gonna talk about DevOps first. So this is how you typically deploy stuff in the old days. So when you look at your teams, you build software before, you have your developers, you do architecture reviews, then you build your software, send to your QA, and send to your operations, and then you run it in production. So it's typically a very, very traditional and very slow-driven approach. I remember when we developed our applications before, it took us 6 months to develop anything, to release anything. And then we did it every quarter, and then it became monthly, became weekly, and it became multiple times per day, which is very cool. And the reason why this thing is quite old and the old way of doing is not suitable now is you're seeing a lot of disruptions that's happening, and you're seeing your competitors or people who build software release often. Remember before Office, right? You see Office, they release software once per year. That was how I see it before, and now people are releasing on a very fast pace. And that also goes with security. Security posture is never permanent. So it will actually change. Whatever's secure for you now is not secure anymore. So this is why DevOps became very, very popular. If you know, this is the DevOps chart that you see online, you see on Google, you see on AWS. This is how they look at DevOps. And what is DevOps, right? DevOps, this is from the AWS website. DevOps is a combination of cultural philosophies, practices, and tools that increases the ability of any company to deliver services at the high velocity, meaning it just helps you deliver value to your consumers as fast as you can. It's not a process, it's not Jenkins, it's not CI/CD, it's basically a culture, changing the way you build software. And we're here to talk about how do you apply this on security. Now, before we start with any security stuff, we're gonna look at the teams. So you have builders. So builders are the guys who build software. Who's a developer here? Developers? All right, so we see a bit of developers here. Cloud architects. Cloud architects? All right, so you're quite the builders. In certain organizations, they have security people. Any security people here? Security guys? All right, few. So when companies builders, when move to the cloud, it actually starts on multiple phases. So the first phase, cloud birth. So what is cloud birth? This is when your company wants to do new projects. Let's try cloud out. The CEO will say, hey guys, we have a new idea. It will only work if you do cloud. Security typically is a leap of faith, meaning, okay, let's get something out first. It's a proof of concept. It doesn't follow the compliance of the companies, and typically it's very cheap because you don't have to, apply a lot of these tools that you used before. And then after that, after your project's successful, you're gonna say, hey, let's actually, integrate it with our infrastructure or our teams. So what's going to happen is there will be a lot of fighting. The cloud team talk to the IT team. You need to talk and you need to make sure this new software that you built in the cloud will work with our existing security structure. And this is where a lot of conflict happens. Because, again, there's two different perspectives, and I'm going to talk to you about that later. The only downside is it can be very expensive because you typically buy two sets of security tools. I'll buy this for the cloud, I'll buy this for on-premise. And then the last one is hybrid groove. And what is hybrid groove? So this is where everybody's aligned. So there's a alignment between the old school and the new school infrastructure and security. Compliance is the same. So meaning whatever controls you have on-prem in your company, you're applying in the cloud. And it's very cheap and it's very efficient. The reason why people get into the cloud chaos is this. This is how developers look at ops people. So developers look at, we're building all this stuff. We're building software, and ops people, they basically run stuff, break stuff, and lock out users. Right? So I was an ops guy before. That's how they look at me. But it's all right. Developers' perspective is, developers like to deploy code. They are paid to deploy software. That is why they are there. They're measured on the velocity of deployments. And as a developer, you want to have the fastest and the newest technologies, right? And ability to deploy in any platform. So I have a new idea. It only runs on AWS Lambda. I should be able to use AWS Lambda to build my software. Now, flip side. This is how ops see develop it. I was in the ops before. That's how I look at things, right? So when you're in operations, you tend to look at all this stuff, right? And you see, developers just write code and test some. But the reality is, if you're in operations, you don't want any surprises. You don't want people surprising you with new things. Hey, this guy deployed this software. It broke our system. I don't know what he did. Standards and controls. You need to have visibility, and you need to know if it's here, it's there. And changes are being controlled, meaning I know what's going on if something's changed. And of course, you don't want regulators always with you. Now we know what's going on between the two teams. How do we make sure that everybody works together? And how do you use a DevOps philosophy to improve your security? My next slide is going to talk about Gartner. So if you look at, if you go to Google, if you Google this, you can Google this, the Gartner Top 10 Security Projects of 2018. We're going to be talking about 5 of these today. And we're going to talk about DevOps in this perspective. Right? So here's our DevOps chart again. We're going to be doing DevSecOps. Currently, in any environment now, if you're applying security controls, you typically apply them on the operate and test phases. So meaning when you're running your servers, you're putting your traditional IPS and your tools, and then on your test phase where you put your static file analysis or your pen testing stuff. The challenge is how do you put tools on these environments, code deploy, monitor, and build. So that's what we're going to be talking about today. In monitoring, how do you put more controls when you're in the monitoring phase? So this is where you're going to put controls like automatic isolation. If you have a server that's in trouble, how do you make sure that you can isolate it so doesn't spread, stuff doesn't spread? Automatic remediation, when something breaks or if something doesn't go wrong, how do you bring it back? How do you heal configuration drift? Somebody changed some configuration on your server, and then how does it come back? How do you make sure that nobody puts bad security group rules? And then how do you automate auditing? So if, for me, we're being audited by PCI DSS auditor before, 3 days before the auditor comes, we're busy fixing our environments, making sure that everything is compliant. So those things can be automated now. You don't have to wait for the auditor to come to do all those. Next one is securing code and using code. So what does this mean? So if you look at Python and the very popular programming languages, right, there's a lot of best practice. All you have to do is look at best practice on how you put secure code. And proactive controls enforced by code. So what does it mean, right? So when I was writing software before, I discovered that there's these tools like linting. So as you write your software, if there's any security problems, it will let you know. It will give you instant feedback. And the last one, my favorite, is using code to build infrastructure. Now, if you're using AWS, there's this very popular technology called CloudFormation. And this allows you to build secure environments without doing the same thing over and over again. One of the challenges when you look at security is you need to have consistency. No surprises. I know that this guy uses template, therefore it's going to have the same security controls as the other. Okay? Next one, build checking. How do you scan vulnerabilities and malware? How do you, when you're building your software? How do you do secrets management? And the last thing is configuration scrubbing. So when you look at configuration scrubbing, this is just based on my experience. When we deploy, AMIs to production, we typically leave the configuration of UAT to production, which is a bad practice. Don't leave, and vice versa. You don't want to leave the configuration of your servers lying around everywhere. So what you want to do is you can use something like Amazon SSM to manage your configuration. Next, deployment security. So you have, when you're deploying, continuous vulnerability scanning. When you're deploying, how do you automate deployment of approved images? So there's also a technique where you can deploy approved images, meaning you can sign images, Docker images or AMIs, to make sure that you're deploying a certified, clean image, and it's being audited by another team. And another one, pet peeve of mine, just-in-time server access. So how many times have you experienced a situation where you deploy the server and somebody needs to fix it? So they ask you, hey, I need to log into the server, I need to fix something. And then you give the guy access. But the problem is, after they use the server, you don't remove it. So there's some techniques as well that you can use so that you don't have this just-in-time server issues. Basically, after the guy uses the server, you need to scrub that account. Now, so those are the 4 techniques. But now I'm going to show you some demos. But because I just flew in last night, I didn't have time to put the demos live, so I have screenshots. It's pretty much the same. So we're going to be talking about vulnerabilities and malware in containers. So I'll give you a challenge here. So the challenge is, how do you verify if your containers in production does not have any known malware or vulnerabilities? Now, to give you a background on this, the way this is a Docker-based scenario. Typically, when you build software in Docker, the developer will download an image from a public repository. Sometimes, the images you download, you don't know how they built it. You don't know the packages that were installed before you got that. And you don't know what edits was happening. And then you're going to put your software in, and then you're going to put it in your registry, and then you're going to put it in your production. So the operations guys, hey, I don't know what's inside of these. And the guy who wrote the software says, it's okay, I got this image from Docker Hub. Right? So it's just another challenge that some teams need to accomplish. How do you just make sure that there won't be any issues or vulnerabilities when you deploy containers? Okay, so if this is Jenkins, and I have multiple builds here. We're going to be talking about 2 of them. So I have your Bryce Web. So Bryce Web, if you look at it, it's got everything. So it's got a checkout, prepare, build, push, scan, and then deploy to production. So this is a very successful build. No problem. No malware, no issues. Next, I have another build. It's called Bryce Portal, and it's got a failure. And you're a builder, right? You're going to check, hey, I want to know if there's any problem with this build. And if you look at the build, it will tell you this part of the build has malwares inside. So you're going to check, okay, what's this command? What does it do? So I'm going to show you Smart Check. So basically, Smart Check is a tool that allows people to scan vulnerabilities and malware in their containers. All right? So this is a check scan. So the first thing you're going to do is I'm going to go to the scan first. What is this failure that just happened? I'm going to look at the scans. And then under scan details, it talks about, hey, there's 3 malware found and a bunch of vulnerabilities. And then you're going to look at more details. So right here, it talks about the vulnerable package installed. So if you look at it, right, it will tell you, hey, at this layer, at this command that you did, this is the vulnerable package that was introduced. So you actually know if there's any problems that were introduced in the software. Same goes for malware. So this is the command that introduced that malware. So somebody copied the folder to var www.html, and it contains malware. And then these are the test malware. Its ability to show you the Docker file will help you to reference it in the Docker file. So if you convert it into code, this is what's going to look like. It will tell you, hey, this app get installed that you did, you introduce a vulnerability or an issue. And this copy command that you did introduced a malware. So that is how you can actually fix it. And so when you deploy to production, you can remove those issues. Now, this is how it looks like. So when a developer commits the code, it goes to Jenkins, and then Jenkins will actually submit it to SmartCheck for scanning. And if there's a problem, it can reject the build and tell Slack. So Slack, reject build, fix it again. Or if it gets approved, you can push it to your registry, like ECR in AWS. And you can deploy it to your cluster, like Kubernetes. Okay? So, next, automated policy assignment. As you know, AWS released a new feature called GuardDuty last reInvent. And I'm going to talk about a little bit of that later. So when you implement it, customers will ask you, what do we do about these events? I have a server that has an activity. How do we make sure that we can secure it further than what we're getting now? So before we go further, I'm just going to show you how GuardDuty works. So basically, GuardDuty looks at VPC flow logs, CloudTrail, and the DNS logs. And based on those data, it can give alerts to the user, or it can trigger a Lambda function to do something. So for example, a server is getting an attack. You can actually do some advanced cool stuff with it. So my example today is, I have an environment with a bunch of servers here, and here is the findings. So we're gonna go deep dive into them. And I have a server that has an IPS inside, but there are no rules. So the thing is, it's basically buying an IPS without any rules means it's not really protecting it. Now, if there's an attack that happens, for example, RDP brute force, right? This is the attack type. It shows you, hey, your server is being attacked. And this is GuardDuty telling you, right? You can actually write a Lambda function. And I wrote this. If you want, you can email me. I'll give you the code. There's a Lambda function that gets triggered by every event. And based on those events, you can put rules. So you can put rules and you can automate. You can tell like the IPS to, hey, scan for rules. Scan a recommendation. And in turn, it will allow the IPS to apply specific rules to the server. So that next time when somebody's trying to, do a scan and they do another attack after that, your server is protected. The server is protected. The main reason why you want to do something like this is when somebody's trying to do a brute force or a port scan, most likely they're going to do an attack afterwards. If they see that you have a port 80 that's open, that has this software, they want to run an exploit, and then you want to make sure that you won't be exploited. And then you got your alerts on Slack. You can send it to Slack saying, hey, there's a suspicious event in GuardDuty. We're scanning the server now for any recommendation to make sure everything is accurate. So this is how it works. So you have a bad guy attacking your server, running a port scan. GuardDuty detects that activity. CloudWatch actually sends a Lambda function, and then it tells Deep Security Manager for scan a recommendation. And then when you do a scan for recommendation, it will apply virtual patching on the server. Now, this is how virtual patching works. So a while ago, we applied the rules. Now, this is how it protects your server. All right, oops, went back. All right, so typically, when you get a 0-day announced, it it will typically take 176 days for people to patch their servers. I know when you're using cloud, it's actually much faster. I know some customers who patch quickly, some customers patch every week, some customers patch every 4 months. But the average of the industry is 176 days. Right? So because of this, you're going to apply the patch, you're going to test the patch, and then you're going to deploy to production. It's like a process, right? There's a vulnerability that came out last August 24. It's already October. I know it's been 6 weeks already. But when we built this demo, it's the day after this was announced. So if you've heard of the vulnerability that caused Equifax breach, this is actually a sister of that. And it's much more powerful. And we're going to show you why. So I have a demo website here. It's the unprotected one. And we're going to show a video on how this machine is being attacked. So I have here a Python script on my machine. I download this from GitHub. Actually, one of our friends wrote this. And it's basically a Python script. And I'm going to show you how it works. So I'm going to run this Python script, and my target is that URL, EKS app. So that's my target URL. And I'm going to type first command, who am I? Now, if you're using Linux or Unix, when you type who am I, it's just going to tell you what user are you using. And if you look at the result is root. So basically, I just ran this command, this Python script. What the Python script does is it generates that string. If you see that big string in the middle called URL, it's just typing it in your browser. It will generate a special string that basically breaks the framework and then allows you to access the server and run commands as root. So if you're root, basically you can do whatever you want on that machine, even without logging in. All right? So we're going to go next. What else can you do with this? So next, I'm going to do an ls-l. I'm going to check what's on the folder. This is what's in the directory. So everything is in there. I'm going to cat etc password. I want to know what are the users with the password. So it's kind of scary, right? But this is what the bad guys will do. So if they know that your server is vulnerable and they can do all of these, they're going to download the file. They're going to download the backdoor. So basically, I'm downloading a file called icar. Icar is a test malware. But we're not going to go further than that. So basically, it was able to download an icar file on the server. Again, this is without any logins, any SSH, any usernames. It just basically creates this URL there. And then when you hit that URL, it can generate that output that we just did. It's basically a remote execution for your server. Now, I have another server that's also unprotected, but it has virtual patching. So I'm just going to show you how virtual patching works. So here's a security view of the server. Actually, that demo runs on Docker. So it's a vulnerable container that I put there. I have the rules applied. And this is how it works. So I'm going to type who am I again. And you're going to see connection reset by peer. So this is a network drop. So the traffic is being dropped. I'm going to do another command. And it says another one. So even if you create that URL, even if the server is vulnerable, the attacker won't be able to go in. It gets dropped from the network level. And if you look at it, under event summary, you get multiple events, and then you can go to the event view. So the event view will tell you this is the attack type and this is the CVE. And it can even give you the details. So this is actual string that I showed a while ago. It can actually reflect you what the attacker is trying to do. So you have the best idea on how they're doing the exploit. Now, it can even go to Slack. So you can get an alert on Slack. So if you're using Slack, it can tell you, hey, this server is being exploited and it's being protected. Again, when you look at virtual patching, this is how virtual patching works. So you have a instance here, and it's got container inside. And then it has host-based IPS. And then whenever there's a 0-day, a rule is being sent to that within 24 hours. So for example, today, a new trust vulnerability came out. The Trend Micro engine will send a rule to that within 24 hours. to prevent exploitation, even if you have not patched yet. And then when you do an exploit to the container, it will be blocked from the network. Okay? So this is how you do virtual patching. All the three scenarios that I showed to you a while ago is basically, if you think about it, it's a three process approach. So you're building, you're scanning for vulnerability, then you're doing a monitor security. So as you monitor your systems, you're automatically applying rules. And then when you're operating, you're applying virtual patching. So this is some kind of you can create some playbooks around this. You can think about how you build your security around this. And of course, you can build feedback. So whatever events you got from your operation, you can apply it and build. Hey, patch the server now. Apply new rule, patch the struts. So that when you start building, you have this continuous loop. And for me, this is not an advanced way of doing DevSecOps, but it's something to get you guys excited or get you started. It's not that hard to do DevSecOps. Few more slides, key takeaways. If you ask me, just start small when you want to do DevSecOps. I'll give you an example. You just do automated auditing. Right? You can get it from AWS. There's this tool called AWS Config that you can use now. You don't have to wait for, you don't have to write a lot of stuff. You need to study secure frameworks. So if you're building software, you need to study how to secure struts. And security team, you need to learn how to code. So it's not just developers who need to learn how to code. Everybody should be learning how to code. And it's very powerful. DevOps is very powerful. You can use it for your security. And the last one is don't be afraid, just integrate. Before we end, I'm just here to say my last word is nothing's permanent and nothing is perfect. What does it mean? Your environment will always change. Your security will always change, right? It's never going to be permanent. But as you build your infrastructure and you apply security rules, it will never even be perfect. So you can never say, hey, perfect environment. Yeah, and with that, I would like to end with this, with the last slide. I think we're going to go to the feedback QR code. Yeah, so I hope you'll leave feedback. That will dictate my salary increase for next year. Thank you very much.
Thank you, Paul. For a copy of Paul's deck, you can approach Jane and Celeste at the front and back of the room to tap your smart badge. So you can do that right now and also fill out the surveys as quickly as you can, as we have more AWS swag to give away. Thank you.